that I've declared now are global variables. And if you've done any programming course, you probably heard global variables are bad. And so how can we do that? How can we deal with local variables? So first we have to, there's two different ways of doing it. But even though, these are, here is var and let. This tells your browser that those are supposed to be local variables. However, in this case, they're not within any block, so there's no curly brackets anywhere around this or no function. So those are still global variables, right? Because, just ignore that for now. But essentially, if you are define something like this in a function or like this in a function, those are local variables and will not be available on a global scope. This var is kind of like the pre-ECMAScript 2015 version of defining a local variable. Let is the new one, and you should always use let. The difference here is that var is function scoped and let is block scoped. I'll talk more about this in a second, but what is also new in ES6 is that we have a const variable, and in most other programming languages, that means that the reference cannot be reassigned, but you can still change any members of an object that you assign to that. So it's not guaranteed to be immutable. It's just it cannot be reassigned. So let's look a little bit more about the differences between var and let, function scope versus block scope. So here is a demo for function scope. I have a definition of var in here. So this is local to the function, var a with 2. Then I have a block. If true, var b is 3. And now I could log the sum of var a and var b here. And so in most other programming languages, this wouldn't work. Because I have declared var b inside the if, and so anything outside the if would not be able to read this var b variable. However, vars are explicitly function scope, which is kind of error prone, which is kind of problematic. And so therefore now with ECMAScript 6, var was replaced by let. And let works basically as you would expect it from most other programming languages. Here I have a let in the function, then I have a let in this nested block. And then if I run this here, this will be undefined. We'll throw an error. So here you see an uncaught reference error, and that is exactly what you want, right? You want your variables to be narrowly scoped, as possible. And then I can also do this, which you never should do. Is I can define a global variable in a block or in a function by simply not saying let or var. So here, global A is going to be accessible from here. And that's really bad, right? Because now you've polluted the namespace of the browser, which is already pretty messed up by everything that the browser does. And you will get into name conflicts and so on. And so this general programming rule is to minimize your use of global variables and always try to define your variable with as narrow a scope as possible. Of course, we can execute operations on any of those variables. So here, some addition variants or subtraction variants, we have the increment or decrement operator. We can do division. We can do the modulo operation. We can ask the type, and we can use the type of operator. We can also assign a string from the return of this type of operator. So it's just a different way of defining it. We can do string concatenation, as in most other programming languages. We can do parsing or casting, depending on how you see it. So here, parseInt is one way of converting the string 13 to an integer. And so here, what I will get is an integer. So an integer is 13. Then I can do parse float on this string here, and then I'll get the float. And then here I'm doing a parseInt on 17.5, which will, of of course, result in 17. This doesn't round, it just truncates, as in all other programming languages. So here is basically how I cast a float to int. So then I get 17. And this is an important operator. That's kind of the shorthand to make this a number operator, the plus in front of a string. You will use that a lot because this is essentially either parse in, parse float, but more better this way is how we read numerical data from a CSV file and make it into numerical data. So that will happen. So that's a very convenient shorthand. You will always see, like in the console, you will actually see numbers, real numbers, as opposed to strings are highlighted in blue. Strings are in black. That's also useful to know to kind of like quickly inspect what you're working with. Okay, arrays I already mentioned that we have arrays. So this is like a numerical array. You can have an empty array. I can access them as I would expect. I can do these multi-type arrays, which you shouldn't. But they do work just fine. You can access the length of an array with the length attribute. You can nest arrays, which is of course very useful for high-dimensional tables. You can push to arrays. You can pop arrays, and so on. And so these are more like lists in JavaScript, or lists in Java, for example, and unlike arrays in a lower-level language like C. So you have all of these, like you don't need to worry about memory allocation, you don't need to worry about what is the size of my array. These are just like these simple lists that you can manipulate as you like. You can pop, you can do an index of operation, and then you can sort. And the sorting here is a little bit odd. Like I'm sorting this array of, where did I define it, number right here, 15, 12, 21, 4. And so what we would expect if I sort this array would be 4, 12, 15, 21. But what I get if I run sort here is 12, 15, 21, 3, and 4. Why?
Because alphabetically it's looking at the first digit, so it's looking at 1, 1, 2, 3, 4.
Exactly. So JavaScript is very much likes to work with strings. And so the default implementation of the sort operation is that it does a string comparison. And so if we don't want to do that, we need to define our own compare numbers function. And here we essentially do that. And then we say num_array.sort compare numbers. And then we get the numbers sorted numerically instead of by their string value. And so that's like a hiccup that you can run into if you don't care about that, or if you're not careful about that. Okay. Now let's talk about objects. And objects are the second type of compound variables in JavaScript after arrays. And objects are these complex things that you can have methods and members and so on, but you can also use them as dictionaries and hash maps or associated arrays. All of those are are basically the same, so you can pick your favorite name. So if you need a hash map or anything like that, use an object. So here's an object definition. I say object, curly brackets, key 1 is 3, key 2 is 4. Okay, and I can access the object either with our dot notation, which is like the preferred way of accessing the member and a member of an object, or you can do the string notation, object of the string key 2. And that works as well, as you can see here. The problem with that is this is, of course, way less robust, because if you change the variable name of key 1, you will get, ideally, you will get a runtime problem. But here, if you change the variable name of key 2, this maybe doesn't change with it. So refactoring is much more tricky here. So you should always use the dot notation and never use the string notation. There are reasons to use the string notations, but you will figure that out on your own if you need to. You can also define objects like this with strings for the keys and strings for the values. And if you look at this, this is exactly what JSON is. And so you probably heard of JSON, the JavaScript object notation. which is kind of the data structure that is very convenient to work with Java, and so we can just read them, and it's basically it will just create an object, and this is how the JSON format looks like. One downside of that, of course, is that here these are not numbers, but they are strings. So if I want to treat them as numbers at a later point, I will have to cast them. So here is the value of string key. You can see that it's actually black, if you can see that, instead of blue here. So it is actually like a string. And of course, you can extend objects dynamically, and that's kind of like odd sometimes to think about. But you can say other object dot whatever you like here is whatever you like, and you can do that at runtime if an object was already created in like a class-based language like Java. That wouldn't be possible. You would need to define this member as a member in the class definition. You cannot dynamically add members to an object. So let's talk a little bit about control structures. These are all quite familiar. So you have your classic if and else, if and else. The one thing here is that I'm using this triple equal sign instead of a double equal sign as in most other languages. Anybody want to say what it is? Yeah.
It's like a strict equality check, so it's stricter than a double equal.
Exactly. So a double equal will do a lot of like magic behind the scenes for you, and it's usually not something that you want, because usually you kind of like make assumptions about what data types you're comparing, and so you don't want JavaScript to make these decisions for you. So you should instead always use the triple operators, and that could be like equally, not equal, or anything like that. And then here we have this type coercion happening. So here I'm comparing if 1 is equal to the string of 1, because I'm using only the double equal sign, this will actually evaluate to true and will print this. We'll just parse that for you, okay? So here, of course, this will not happen, and so string and int are not the same. This is, of course, a much safer way to do that. We also have the ternary operator. That's condition, question mark, what happens if condition true, colon, what happens if condition false. And that's a very convenient shorthand, especially if you have like not very long conditions. So for modulo 2 equals 0, then console log true, else console log false. We also have switch statements that work on strings. So here I'm letting I be some case, and then I'm switching this string, and then string literal. I can just like put in string literals here, and this will actually match. So here you see switch matches appear on the right in the console, and then you also have the default. The default is actually always happening. So if I remove the break here, I get both the switch matches and the default. This is also familiar from other programming languages. So loops are also, like there's a couple of special things, but the basics are similar. Here is a for loop with an increment, with a counter. So a for let e equals 0, e smaller than 10, increment I. It's then the output, here I'm just like incrementing this output, and then I can see what the output of that for loop is. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I can do a while loop. Here I'm defining I outside of the while loop, and then I simply say while I is smaller than 100, output, do a string concatenation, and here I'm multiplying I by 2. And so you get the sequence of 3, 6, 12, 24, 48, 96, and that terminates quickly then. You can also do a do while loop, which is exactly the same as the while loop, but it's guaranteed to execute once. And you check the condition afterwards. An important way of working with data structures is a for each operator. And so there's a couple of different ways to do this in JavaScript. This is kind of the classic one here. I have an array of years. And then here I'm saying years for each, and then I pass in a function. And that function does something. Like, for example, in this case, it just logs it. And so that's the way JavaScript was written all the time. even a couple of years ago. And if you know that syntax and that's familiar with you, that's okay. That's not a big deal. That's very useful. But in many other programming languages, you have like a for each statement, for each element in collection. And so JavaScript didn't have like something like that, or at least not something that works reliable. So it does now, but it's not for each, it's for of. So for let here of years. And the important thing here is that the of is really the key, because there is also a for in years, but that like here for years of years actually goes through that collection in order. But for year in years does not go through the collection in order, but it goes through the collection by the order it's stored in the object, which in the simple case here is identical, but can lead to problems. So in the end, you really always, basically there is not really a reason to ever use for in. You should always use for of. Okay, so functions. We already work with functions, and I've assumed that you guys know what functions are, but formally functions can be defined in a couple of different ways in JavaScript. We have these like classical function where I start with the function keyword, the function name, and then I pass in a parameter. And then I can use this parameter as a local variable in that function and then execute that function. So let's clear this. So here I run this function that simply checks if v is smaller than 10, return v, else return v multiplied by v. And so if I run this for 30, I get 900. If I run this for -5, I get -5. But then it gets a little bit weird. If I run this for a string that contains 50, JavaScript will, what it likes to do is it will try to guess what you try to say, or make some assumptions and treat 50 as a number. So function for a string that can be converted to a number will actually give you a number. So it will automatically try to cast. And then for functions for strings that cannot be converted to a number, JavaScript still tries, failed with the conversions, but doesn't give you like a runtime error, but simply gives you then not a number. And then finally, I can also use this function, and again, without any runtime error, without any parameters. And it will execute, it will assume that you actually wanted to say undefined. So these are some kind of tricky assumption that JavaScript makes that other languages usually don't make. It's just something to be aware of. So all of these calls work, but they either result in not a number or they do some type cursion. Oh, and I forgot to mention this one. You can also pass in as many arguments as you like. JavaScript will just take as many as it wants and ignore the rest. Again, rather strange. There is an alternative way of defining functions, as is common in a functional language. Here I'm assigning a variable, like a function expression to a variable. So here I'm actually saying let variable function is function, and then comes the function definition. And so I'm doing this simple if v is bigger than 10, then return big, otherwise return small. And let's look at what this does. So if we run this variable function of 30, it just works as before. But we can then also later reassign our variable function here, like any other variable, right? We can just give it a new value, and so we can do a new function that now has a completely different return type, that does something completely different, but that's perfectly legal to do. So this will return 25 instead of big. And so this is a key thing, that functions are variables. They can be passed into other functions as variables. They can be returned. And so they're completely flexible in the way how we use them. Here is an example of how we use such a function with the map expression. So this is now, like what we did here is we assigned the variable function to, like, we assigned this function here to a name variable function. So this was a name function. But now what we're doing here is we're using these anonymous functions or also lambda abstractions to essentially pass in this function and define it in line without ever giving it a named variable. And this is going to happen a lot. We'll see this a ton in D3. So we have something like myNumbers.map function d return d multiplied by 2. Okay, and so what this is exactly the same as if I declared the function separately, assigned it to a variable, and then passed the variable in here, as I did in the earlier example. And so these like anonymous functions are extremely common in JavaScript. And then this is the new shorthand notation of that. So here I'm doing the same thing as before, but I'm using the arrow notation that was introduced in ECMAScript 6. And that is very convenient because I do this so much. Instead of doing this complex definition up here, where I do function d square curly brackets return d multiplied by 2, I simply do d arrow d multiplied by 2. Okay, so that's all you need to do for that. And this is also something that you will be seeing a lot in modern JavaScript code because it just shortens the code so much, and once you get used to it, it becomes very familiar. We can also, there's many different flavors of that. We can use, here we use the arrow notation for a function that doesn't have a variable, that doesn't have a parameter. So in this case, we just do empty brackets arrow 12. And that works just as fine. And if we have a function, here we have a function that multiplies a parameter. Again, we just use f2 equals x arrow x multiplied by 2. And then we can also use functions with multiple parameters if you put them in curly brackets like x and y, and then arrow. And then we can either do, again, an expression that directly results in a return statement like here, or we can also put in a block statement. So you can say, now do this. And as soon as you start the curly brackets, you also need to include a return statement, an explicit return statement. So here, the return statement is implicit. This expression is returned. In that case, if you use the curly brackets here, you need to make that return statement explicit. Of course, you don't need to return something, but if you want to return something. So, questions about this? Everybody familiar with anonymous functions and arrow notations? Yeah.
When you use dot map operator, can you repeat that process?
Sure. So .map is just a function that does something to every element in a collection, right? .map, if I have an array 1, 2, 3, and I want to multiply each element in the array by 2, then I will say map multiply by 2 function. I can either define this multiply by 2 function as a named function, or I can define it inline if it's a very simple thing as I did it here. So d arrow d multiplied by 2. That is essentially our function definition for multiply your input parameter by 2 and return it. And then that passes into the map, and that is then applied to the whole array. Other questions? Yeah.
What's the difference between map and for each?
Map applies it's a good question. Map assumes, I think that, I'm sure there is one. I don't want to say something that's not true here.
So what would you typically use?
I would personally, I prefer to use the for off notation because I think that's easier to read. But it depends. Mapping is basically you transforming an array. And for each is you're iterating on an array, so you actually don't have to transform that array. But you should look up the documentation. Do you know the detail?
I think so. Map, you're going to return the return value is something new. The original one is unmutated.
Yeah.
And I think in the for each you can mutate the array in place if you wanted to do that.
Yes. So I guess the best distinction is map. Use it if you want to manipulate the underlying array. For each, if you want to iterate over it. So, now let's let's talk about object-oriented JavaScript. We talked about objects as data structures, but not really as like these complex things that we use for object-oriented programming. As I already said, JavaScript is a prototype-based language, and that means there's no class definitions, strictly speaking, at least under the hood. We can use objects though to kind of like do that. And before ECMAScript 6, we actually didn't have like this looked a little bit strange. We used essentially functions to create objects and to define a class signature. And so here is our function create object, and I pass it some content. And in that function, I define a local variable result that contains an object. The object get is a function that returns the content. The object set is a function that takes a parameter, new value, and then assigns new value to content. And then twice is a function that multiplies content by 2. And so we've done this now without even like having the word class or object, but this works very much like an object, right? We now have, we now can create an object where you pass in something by calling this function. Then we have an object that has a getter, a setter, and then it has a method that does something and returns that. And so let's go through the output here. We create an object something, and then we get like f.get. We get something like something back. Notice that this is a string. If we do it twice here, it's of course undefined because we can't multiply a string. But then I can do object.set 20. Now I've set it to be like a number. Now I can do the get and I can do the twice, and it will result in 20 and 40 respectively. So this is a way of kind of like faking object-oriented programming. Now, of course, one important aspect of object-oriented programming is inheritance, right? So if I have like a class animal, then I have a derived class dog, and then a derived class cat, and then I have a derived class labradoodle from your dog, and so on. And so you've probably heard of all of this. And in JavaScript, this is implemented as prototype delegation. So that means that you basically have different objects that are chained together. So here's a simple example. We have a base object that has v1 and v2. Then we have a derived object that's only called derived here. We actually haven't derived it. v1, v3, v4, missing v2. And now if we log this, we'll see base v1 is 1, derived v1 is 5. So these are not the same values. Derived v2 is undefined. Derived v1, okay, so maybe this is now where we do the prototype delegation. So here we say object, which is just a global identifier, set prototype of derived to be base. And now by using this call, I've said base is the parent of the derived object. And this is like dynamic. This is really hooked up dynamically. And now I can actually do I can access the derived object. I can access v1 as it is, and v1 will give me what was overwritten in the derived object. So what happens is, behind the scenes, it will look at what is the highest level object or the object that I'm referencing in. If that variable exists, it will return that. If it doesn't exist, it will go one step up the prototype chain and then return the variable if it's defined there, and otherwise continue going up the prototype chain. And so here now in the derived, we can actually access v1, which is defined as 5 here, but we can also access v2, which is actually only defined in the base class, and that's because of this prototype delegation. So it's similar to inheritance, but the difference here is that it's like dynamically at runtime and with objects instead of class definitions. And so here's another way of doing this. Instead of set prototype of, I can simply say an empty object create null, and null here is the prototype, so we don't have a prototype. Then a base object create empty object, and then a derived object create base object. And so this is how we can do inheritance and chain that down. Questions about this? Okay. So fortunately, this is if you get your head around it, it's actually not too tricky, but having a proper class notation is useful, especially as a reference if you want to look up what is actually defined on my object. And so I strongly prefer this class notation, which was only introduced in 2015. And so this is probably quite familiar. We have class base, then we have a constructor where you pass in a number of parameters, and this is how we assign member variables. So this dot first is first, this dot second is second. And then here we define a method. There we can use our member variables to do that. And so if we do a base instance is new base of 2 and 4, we can say base multiply, and that will work just fine. The extension, the derived, is also simple to do. We say class derived extends base. Then we put in a constructor. Here we have first, second, and third. We call a super. So that means that the super class is now instantiated with the first and second parameter, and the third is only defined in the derived class. And then we override the multiply function here to actually multiply all of those 3 variables. And so this works just as we would expect it to work. So we can see derived multiply results in 48 for input 2, 4, and 6. So that's quite familiar.
So do you put explain what super is?
Yeah, so super essentially goes into the extend base. So what super does, it calls the constructor of the base class, of the class that it extends. And so you see that super here has a first and a second. So 2 parameters, this corresponds exactly to the 2 parameters of the base constructor here. Okay, here's another tricky thing about JavaScript. This can have different meanings depending on how you access an object. So here is I'm using this function notation again to define an object. I initialize an object with value, assign x with value, then define a getter and define a setter. Okay, and so all of this is fine if I do it like this. So here I've simply said let other be other object of 3. Then I can access that other.x directly, the value here directly. I can use the getter. I can get after set, and that will return the right value. And I can retrieve x as 5, as you can see here. All of this works. So this is simple, and this is fine. The problem is that JavaScript changes this based on the calling instance. So it's assumes the context of the calling object. And so here is kind of a scenario where this can go wrong. This is all the same here. I'm initializing, or not the same, but this is a similar definition. We have x is 3, and then we have a getter. And then here, I create this object, and then I use the get function here, and this works as expected. But now I'm assigning object.get to a global variable of name t. So I've now assigned this function to a new object that's not part of the other object. And then if I try to access the value, if I simply try to access t, it actually uses this here, refers not to the object that I created here anymore, but it refers to the context of the object that we created here, which in this case is just a global window object, and so we lost that information. And this is why we often do this that equals this assignment to keep this context explicit if we potentially run into these problems. So a couple of other interesting syntactical things in JavaScript. If you want to, you can define default values like this, and I'm going to skim over those pretty quickly because I have a lot of other stuff to go through, which I really need to, but you can read this in more detail. So I can default variables like this. I can also do lazy expression, what JavaScript does is lazy expression, so I can assign a function to be a default variable, and that is only executed if foo is called without a parameter. Then there is the gather and spread operators. So here I have for spread, I have a function that takes 3 parameters, and let's assume I have those data values that I want to pass into a function. I would have to say like array index 0, array index 2, array index 3. But with the spread operator, I can simply say dot 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 array. And it will spread it out in the order it's in the array to the order of the arguments for the function assignment. Similarly, the gather operator, so here I can say function foo is x, y, dot, 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 z, and then I pass in 1, 2, 3, 4, 5, 6, 7, 8, 9, or whatever. What will happen is that it will actually take 1 and 2 as regular parameters, but make gather z, everything that's passed after that, into an array. So now I have 1, 2, and then an array with 3, 4, 5, 6, 7, 8. So you can very flexibly use, pass in data. Destructing is quite useful to assign, like if I have if I return, for example, an array from a function, it's quite useful to use destructing. So what happens if I have a function that returns an array, and previously what I had to do is I used a temporal variable, then assigned a to temp of 0, b to temp of 1, z to temp of 2. And then I can access those. In ES6 I can now do let xyz in an array bracket and say this is the result of foo. And now the variables x, y, and z will be defined automatically as local variables. I can do the same thing with objects. So here we have a, b, c, and then I would have to assign a temporal variable and then assign those individually. In ES6 I can simply say let ABC equal foo. And this is kind of the shorthand of this more explicit notation. A is A, B is B, C is C. So you could have like whatever my variable name here, and that would be assigned to A now. What is also new is template strings. Before I always had to do string concatenation to create strings that contain some data types, but now you can do like with these like slanted quotes, single quotes, and a dollar notation. You can actually refer to strings as in some other programming languages. So you now have both options here. And so there's many other features, especially modules and promises are two things that are important if you build a real piece of web software. But I'll be skipping over those. We won't be needing those in the class, but you should definitely take a look at them if you're ever need to do some web development. So now let me jump to any questions about JavaScript? Yeah.
Yeah, can you do dynamic variables or dynamically create variable names?
I'm not aware of. Well, you can always dynamically create variable names by using the string notation in an object. So that's possible. But I'm not sure what do you mean?
I don't know, you have the array of values and you want to store them separately.
And then the variable names, how would you define them? So that's, I think that.
I was thinking of MATLAB code for
Okay.
eval.
Yeah, I'm not familiar with MATLAB, but not that I'm aware of. So this bracket definition for this auto expansion is the best that I'm aware of. Okay, so DOM manipulation. So this was all just basic programming. Now let's talk about DOM manipulation. So now we'll again have these combinations of HTML code and JavaScript code. So first, here we have our HTML boilerplate, and we have a script definition. And then the first thing that I'm doing here is I'm logging the document object. And the document object is kind of like the interface that you use to access the DOM. And so the DOM, this looks very much like what you would see if you just open up the inspector, right? So the document object is kind of like your main interface to that. And the document object defines also an API. And by that, you can manipulate whatever is on the document, in this document object. For example, here I'm say document.getElementById, main div. And main div is something that I have defined up here in this line. So I've given div ID is main div, and then I have text in HTML. So we can now log this main div if we wanted to. This is like what I did here, and you can look at that. But then we can also create a new paragraph element. We can say document.createElement paragraph. And then we get this new paragraph element, and then this to the new paragraph we say append child document create text node. And so now we're creating a text node that's inside the paragraph, and then we specify the content of the text node. So here's some text at the new paragraph that was created dynamically in JavaScript. And then here we append it to the main div. So we have this paragraph, and then we get this like website here where we had text that was specified in the HTML, and then here we have some text that was dynamically generated in JavaScript. So that's the first time we actually dynamically generated the website. And just by using this kind of syntax, I could actually do, like this is what all the libraries use behind the scenes, right? They use these standard API to manipulate that. DOM, it's just like these libraries like D3 or jQuery just make it simpler for you. So I don't want to spend too much time because I want to also talk more about D3. There is like this get element by ID. There is a get elements by class. There's create element. There's create text node, append child, and so on. So now we can make more complicated programs. Here we create like we have a function now, the div with text. So we have again our main div. We say create element div, create text node text, append child text node, return div. So this is a function that does all of that, and we can now here dynamically create that. And this will do like in a loop. We call this div with text for certain parameters, and then it will dynamically create our HTML page based on the values that we have in the for loop. So 0, 1, 4, 9, 16, and so on. And then at the end I do like one more manual addition and append X. So now we've like created a function, and now we could like create arbitrary large HTML documents. We can also, of course, control the attributes of elements. So what I'll create here is like this beautiful, colorful, and well-positioned text. So I have the div with text as I had before. Then I have like a text add function that does our positioning by saying node set attribute style position absolute. So you remember this is from like just CSS. And then here I'm doing like I'm using some programmatic like these parameters that I pass into the text add function to control the position, the x and the y position. Then I'm using X and Y to also control the color. I'm using the HSL color model. Use X modulo 255, like because this is like how many colors we can specify. 100% saturation, 50% lightness, and then we create like this creates those colors, like the position and the colors. And then here is just the stuff that I need to do to actually create multiple of these instances. So now this is now like all colored, positioned, and created dynamically. We can of course do things like this now. So it reminds me of 90s websites, but similar trick. I'm gonna skim over most of this here. But what I want to say is like, how do we do this animation? We have a tick, and this tick updates all of our nodes. Let node of nodes. These are the nodes that we created dynamically, and then we update them here. And now we would need to keep this animation running. We need to run an endless loop, right? But we don't there's a special trick that you have to do here, because otherwise you would get into the problem. So what we do here is like we have a tick forever that calls the function tick, and then we use an API function of your browser that says window request animation frame tick forever. And so if I just did a recursive call to tick forever here myself, what would happen? Exactly. It would eat up all the CPU cycles. My program would keep running, and eventually Chrome would crash, and you would never see a single number. So I need to run an endless loop though, but by using this request animation frame, I'm telling the browser, next time it's convenient for you and you redraw your page, let me know and give me a callback to tick forever. And so now I've basically defined this recursive function, but in a way that kind of like the browser has time to do everything else that the browser has to do. And we were not running into the problem of overloading our CPU. Okay. One last important thing is not directly document object model and working directly with that API, but it's events. So we usually want to react on something that the user has done to our website. And so here we have like two different buttons and a div. And this is what this looks like. So we have click me, no click me, and then can you also click me text field, right? So this is what the HTML here does. And then we define this in two different ways. We can either say onClick is message me, and I'm actually saying onClick call that JavaScript function. Or I can give the button an ID. And so here's the message me function, and that will just be called whenever I click this button. And this says yes, it's me button 1. And if I click this button, you can see yes, it's me button 1. The alternative is to use document get element by ID, my button on click equals function, and then the function definition. And then see, you chose me button 2. That works as well. And of course, buttons are just a convention. I can actually look for any object on our website. I can like have this event for any object on our website. So here I'm using like this div message. See, you don't have to be a button to be noticed. That works equally well. So and you will very often create like SVG elements that are clickable or hoverable or anything else like that. And you will rarely use actual buttons for that. And this is a drop down. I'm kind of like worried a little bit that I'm not gonna get through the D3 stuff. So maybe I'll just go through my D3 things, which you really need for the homework, and I'll come back to this later. So any questions first about the document object model and the standard API? Like I've only skimmed over it, but there's of course plenty of documentation out there. Okay, so let's talk about D3. As I already said, like D3 is just a front-end library, like a bunch of JavaScript code that makes things simpler for you. D3 was like published in 2011 at the Infobis conference, and the great thing about D3 is both that it is like a well-documented and well-written and super useful library, but there's also a million examples on the web, and all of them are like publicly accessible. So it can be quite great to simply look for what have other people done and then basically create a mashup. So D3 can be used to manipulate pure HTML, but most commonly it's used for SVG. So you could use D3 to do stuff that you would do with jQuery, but usually it's done like you use D3 to manipulate SVG, and usually also in a data-driven way. And I'll talk more about this. And here's an import definition for like importing the D3 library. You will see sometimes d3.v5.min. This is the minified version. I recommend as long as you like write code that you develop, I wouldn't use the minified version because then you can just step into the library itself and look at how it's implemented. So I would rather use this usually. So I'm using the minified version in most of these examples here, but in your homeworks you should, for example, use the regular, not minified versions. So here's a very simple D3 program. So we have a body with 2 paragraphs. Here's a paragraph and 1 more. And now we have our script. I've included D3 up here. And all I'm doing now is I'm saying paragraphs is D3 select P, and then paragraphs.style color steel blue. And so now this paragraph has turned blue, the second one has not. So what have we selected on here? This is like a CSS selector. This is like document dot get element, or I'm not sure about the syntax, but this would be like this: get element by. I probably wrote it down here. Get element by tag name would be the equivalent function for the standard API. And then instead of set attribute style color is steel blue, we use the shorthand paragraphs.style color is steel blue. Okay, so this now only applied to the first one, and obviously we also want this to apply to multiple ones, but I'll talk more about this in a second. In the standard API, I distinguish get element by ID, get element by tag name, or get element by class, or get elements by class. In D3, it's just select, and then you put in the correct syntax like in CSS. So here you have D3 select P for an element, you have D3 select hashtag second for an ID, and D3 select dot other for a class. And then I have, of course, like defined here a paragraph with ID second, class other in that case. And so here this will select our first paragraph element. This will select the second element with the ID here, and then this will select the class, the first other class. And so we see these colors here. The fourth paragraph is actually not styled at all. And so that's again because we've only used select at this point. So to select more than one element, we can simply use the select all function. So now this will actually select all of the paragraphs on our website. Okay, and so here now if you style them, all of these paragraphs are actually styled in blue. So this is now kind of illustrates the declarative approach of D3, because if you think of this in like an iterative way, D3 select all P gives you an array of objects, an array of paragraphs. And in an iterative way, you would say for each element in P, apply the style. But D3 doesn't do that. It's more, it more specifies like what you want to do to the set of the object, similar to the map function that we talked about before. And so we don't, like PS now contains this, this collection and does everything that you say to the whole collection at the same time. And then we will see how we can use the data to do this in a conditional way. But this is kind of like the most important point for you to get today. How this is like really a declarative approach and not iterative. So like most of the programs that you will write with D3 have no for loops at all. And even though you create many objects that are of a similar type, but basically think of it, whenever you write something in D3 and you want to do a for loop, you probably shouldn't. So you should think about another way of doing it. We can of course also define arbitrary properties with D3. We can do things like like here we append a span with and so to dynamically create text. So here we select all of these four paragraphs, and then we append a span, and to that span we append text. And so now you see we have those 4 paragraphs, and then this dynamically created text. And so this is like all the JavaScript code I need to do that. So this now is just like a short code snippet that I can use to run the following examples dynamically, because I usually want to distinguish between an initialized state, like this is an SVG that I've drawn in HTML, and then I do something with it in D3, and then click on the run button, and it will do something in D3. So this is like just the code that does this running and so on. So basically ignore this. But so what do we have here? Now, the first time we are actually using select D3 to style an SVG. And so there's a couple of things that you should notice about this here. Method chaining, anonymous functions, and arrow functions. So we have our SVG defined, which has these like not very like beautifully placed rectangles. And now we have this. Here is the D3 code that is important. So here we say D3 select all rectangles, and now we have selected all rectangles that we defined up here. And then we apply attribute X and 0. So they all start at position 0. Then we say attribute y is now a function. And the function has two parameters, d and I. And d, we'll use that later, that's like a data object, and I is the index. And so I is the index of the elements. Let's say if I have 3 rectangles, the index of the first one is going to be 0, the index of the second one is going to be 1, the index of the third one is going to be 2. And so by running I multiplied by 90 plus 50, the first one will be positioned, or the I position of that element will be 50. And then here for the width, I say d and I, and I'm again using only the index I multiplied by 150 plus 100. So the first element will be 100, the second element will be 250, and so on. Yeah?
So the I is just implicitly found, so after you define which rectangles or group of elements to select,
Yes.
it's implicitly defined in that
The
selection.
order, exactly. And the d will be the data that is bound to that specific element. I is the index of the specific element as it appears in the DOM. And so now, notice also like here I'm using an explicit anonymous function. Here I'm using the error notation. And again, these are equivalent, and we'll be using a lot of the error notation because it's just so much shorter. But you can use either of those two. And then I'm styling all of those elements in P as steel blue, and this is now my result. So now I've created a bar chart in D3. Okay, now the most important thing about D3, data. Now we have done this only with those indices. We have completely ignored that this bar chart could be data driven. This is just based on where the position of these elements is. And so the key thing here is this call here. So we say svg.select all rectangles, bind data to the rectangles that you find in your selection, and bind to the first element that you find, bind 127, to the second element, bind 61, to the third element, bind 256. And this is really the key thing. The DOM elements, really what the SVG rectangle that you see on the website has this data set now associated, or these data items now associated with them. And then I'm simply doing things like, with this X and Y as before. Here I'm now doing the first time we are doing data-driven styling. I say width of D is D. And I have to use the function notation. I can't just say D here. I have to use the function notation because this is like, the D is like this calls for a function here. So to retrieve the D, I need the function. And so now if I run this, you can see that we have bars that correspond to the values that we've selected here, 127, 61, and 256. So this is roughly 2 times as big as this one. Okay, so this was our first time ever data-driven styling. We had the width of the rectangle that we did based on a data array. So now what happens if we have more elements in our can, or if we have more data elements than we have rectangles? So here we have 4 rectangles, and then we simply say select all rectangles dot data. So what's going to happen if I click run? I'm missing my 4th element. So I have the 3 elements, but I haven't really taken care of what happens if this element didn't exist before. So here I only selected all the rectangles and bound the data to those rectangles, but I didn't tell it, oh, if there's not enough of those rectangles, please create new ones. And so now we need to tell D3 to actually do that. And so this is how this works. We simply say svg select all rectangles dot data, or wait, yeah, svg select rectangles dot data, and then here I'm styling this again. And this is the key function of this code snippet here. Selections actually is composed of a couple of different selections. Select by default, the selection that I get from select all are the element that already exist. After I've done the data, I might have elements in what's called my enter selection. Now I have an enter selection, and that enter selection only contains the element that didn't find a partner in the existing SVG elements. So these are basically uninitialized void objects, or void DOM object at this point. Now I'm giving them something, like I'm x, y, width, and height, and then I'm styling them green so that we can see, that we can tell apart the new one from the old ones. And so if I run this, what I'll get is I'll get 3 bars that are styled in a data-driven way, and then I have created this new green rectangle here. Okay, question, what happens if I click run again? It will turn blue, and it will also find its own position. Why is that? Because it already existed in our SVG. So we dynamically created that, and now the second time we ran this, we were able to apply this with the update selection. So now, of course, this isn't like clicking something twice is obviously not the right thing to do. So what we could do is we could take our update selection here and style it the way we want, and then we could copy all of the code and simply say enter.append rectangle, and then all of the others, the style code again. And of course, this is going to work. So we can see we now get 3 ones that were defined with the first function, and then just for illustration purposes, I've defined this one here to be green instead of blue. So that's fine, but why is that not great? Exactly, I've created a code duplication. So that works if you just want to debug it quickly, but you should never have code like this eventually. So here's instead a shorter version. And so this is like now the trick. We have SVG select all rectangles, and then we do the data binding. And that now like creates our update selection that contains as many elements as we had in the SVG before, as many rectangles, and then additional uninitialized objects. And what I'm doing here is I'm using the enter selection and say dot append rectangle, and then here I'm making those uninitialized objects to be rectangles, and then I'm merging it back into the update selection. So like this here gets us the enter selection. This here makes them rectangles, and this here merges the enter and the update selection. And now we have like one set of rectangles, and now we can just use our selection here to style this one set of rectangles uniformly. And so if I run this, I will get those 4 rectangles. Questions about that? Because if you get this, like this is basically all that D3 is, and there's like lots of extra library functions, but this is the principle behind how D3 works.
So just like practical cases when we'll run into using this selection feature, when what's a certain attribute on a page has more data than we can display at a single time, or?
Well, so if you have too many elements to display at a single time, you'll have to do something smarter, some filtering of your data. You'll have to do that manually. You can create an infinitely large DOM, but the user will have to scroll away, and that's not ideal. And so you'll have to, this is like a higher level question that D3 cannot really handle. Yeah?
This is probably really dumb. Can you do selection.enter first, and then just have it all run in one line?
What do you mean by selection? You can do like,
Handing the 2 things to the data to your SVG elements. Just take all the initialize.
so yeah, you can do, if your question is, can I do this with an uninitialized canvas?
Yeah.
Yes, my next. Like here, I have an uninitialized canvas, and now I click run, and I created it. So I can actually do something that is a little bit bizarre. I can select stuff that doesn't exist. So here I'm running select all, even though there is not a single element in our SVG. So you can see, here's the SVG. It doesn't contain any rectangle. I'm still selecting a rectangle. And then I'm like here, I do data binding, so that creates these uninitialized 3 objects. Here I'm running the enter, append, and I'm actually doing, like I'm not merging this here, because this works now but this works because I'm only doing it once. In real production code, this would need to be merged too. Here I'm creating those rectangles from void, basically. So, quick question, what would happen if I did P here? It's actually valid, because I have nothing that I select for in the first place. So what really is important is that I have initialized the selection, I have bound the data to it, now I've created those empty objects, and then I will do that, I will create rectangles. However, this is extremely discouraged. Vadim Ogievsky, one of the co-authors, I saw him give a talk once, and he actually said, if you do that, I'll find you and shoot you. I'm not going to shoot you, but you should not do that. You should select on what you're actually creating. So here this should be like this works, but you shouldn't do it. You should have like the rectangle, because this is going to make your code more robust if you have like a merge of your existing elements and if you do some updates. So similar to entering, it can also happen, like here we have 3 rectangles. It can also happen that we have less data than that. And so if we now ran this, we would have this leftover element here. And so we can simply treat like the enter selection, the third type of selection, like the update, the enter, we also have the exit selection. And these are the 3 selections that we need to deal with. And so what we do here is we say, like all of our regular styling, and this is the only line here that is new, selection.exit.remove. And that removes all of the elements that didn't find a match in the data set. Okay, and so now if I run this, you will see that I have 2 different bars here. So this is kind of a summary of like these selections. Here we have all the data elements will be in the data elements that are, or the data points that are not, that don't have elements will be in the enter selections. The data points that also find matching elements will be in the update selection, and the data points, like the elements where we don't have matching data for, will be in the exit selection. And these 3 selections is what I usually have to handle in a D3 code. So now this is all like very basic. I can of course create this stuff easily, but what is actually a little bit trickier to do is something like this, a smooth animation. And so you would imagine that this is a lot of code, but in fact, because it's a library, it's only those 2 lines here. You simply say dot transition and then duration. And that takes your previous state of your SVG and then transitions everything, interpolates position and color and so on into the next state. And so that's a very convenient thing, and you can make pretty fancy visualizations with that. Here we're again missing the enter. Like if you wanted to combine now enter, exit, merge, and transitions, we would end up with the code here. I'm actually doing 2 transitions. So like what happens here is the enter will appear red, then they will all transition, and then 3 seconds will pass, which is what you see here, delay 3, and then transition it into green and larger rectangles. And so I can chain those transitions, and I can actually put in delays to create animations like this. So the last thing that I wanted to talk about is lines, because now we've only talked about bars and rectangles, but bars and rectangles is actually all you need for your homework too. Well, you'll actually need a line, but that works just as a rectangle. But if I want to have a path, this would be like if I have a line chart like this, I could create it like this. I could, oops. So I could create a line chart like this by simply using the SVG path element with all the like syntax that you used in your homework. But that's of course very tedious and it's not very data driven, right? Here I put in those things like manually. And what I can do instead is I have a point object. Then D3 has a line function. And for the line function, I simply say, given this object, D3 line, and line wants an x and a y value, and we have our object here that has x and y values, so we say our x, d is dx, our y, d is dy. And so now we tell D3, this line function, how to handle, for this given data structure, how to handle that line. And then we can simply say SVG append path, and then here to the path, the D attribute is the line function of our points, of these data points. And so that's a little bit different. Here we don't have the data explicitly bound to these objects, but D3 makes also this easy. And then I can actually do things like making this into nice curves, also very easily. Okay, so that's the overview of D3. You should have all the basic skills that you need for homework 2. We have office hours. There's a lab tomorrow where we'll go over that again, also with a little bit more specific ideas about the homework. And then we'll continue with JavaScript D3 next Tuesday, and on Thursday I'll talk about the visualization algorithm.